Hi dear students, welcome back to our channel and Vinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the one of the important topic to draw the ray diagrams and to draw the images found by the concave mirror. To draw the images formed by the concave mirror, which rules we have to follow. So for that you must know about the ray diagrams and how to draw the ray diagrams and what are the rules during the drawing of ray diagrams. Let's discuss. Here, what is meant by a ray diagram? A ray diagram can explains how the light rays are coming from the object and after incident on the mirror, how they can be reflect. That should be explained by one diagram. The diagram is called ray diagram. A ray diagram which can explains how the light ray is coming from the object and after the reflection how the light ray can moves. It was clearly given in the ray diagrams. Okay, let's see here. What are the rules to draw the ray diagrams? Let's discuss. Rule number 1. The light rays which are coming from the object, if they are parallel to the principal axis, after reflection they should be passes through the focus point. This is the rule number you have to remember. What is that? If the incident ray is parallel to the principal axis, after reflection it can passing through the focus point. Clear? So here let's see for concave mirror first. This is the concave mirror. Clear? And I am showing here it is the principal axis and this is the point. Midpoint of the mirror is what we call pole. Clear? The ray which is parallel to the, this is the ray is parallel to the principal axis. Here the arrow mark indicates the direction of moving of the light ray. So this is what concave mirror. This is the non-reflected surface. For concave mirror, non-reflected surface is outward and reflected is inward. This is what concave mirror. Clear, students? And now after reflection, that is passing through one point on the principal axis, that point is what we call focus. This is the incident ray and now it is the reflected ray, and the reflected ray is having some arrow mark is outward and this is towards the mirror and this is the away from the mirror. Clear? This is the rule number 1. And here in case of convex mirror, how we can draw this one? Let's see here. We need some space, that's why I am drawing like this. So this is the convex mirror, this is the principal axis. Clear? Now the light ray is coming like this. This is the incident wave and here this is the reflected ray. So this is what? Incident ray and this is the reflected ray and this mirror is what? Convex mirror. So here the reflected ray should be goes like this. If you can extend the reflected ray like this, then here that point is here focus. While we are extended the reflected ray, that should be meet at one point. That means what? Here we can see that the reflected ray seems to be moving from the focus point. That's why here the convex mirror can forms the virtual image and concave mirror can forms the real image. So here you can observe in the case of concave mirror the reflected ray is directly passing through the focus, but in the case of convex mirror the reflected ray is that is going to be extended back, then only that should be seems to be passing through the focus. Here you have to observe, for a concave mirror or convex mirror, the rules are same. Here what it is, the ray is parallel to the principal axis, after reflection is passed through the focus, and these are same here. The incident ray is parallel to the principal axis, after reflection, that is seems to be like it is passing through the focus. Now let's discuss about the second rule. The rule is, if the ray is passing through the focus, then after reflection it is parallel to the principal axis. This is the conversion of previous one. If the ray is passing through the focus, after reflection it is going to be parallel to the principal axis. So let's discuss for both concave and convex. So this is a concave mirror and this is the principal axis. What is principal axis? Now the ray is S. This is the ray and that should be passing through the focus, and this is the pole. Children, the concave surface has non-reflection is outward. Got it? So this is the concave mirror. Clear? So after reflection, so we may extend like this also, don't worry. So here after reflection the ray is passing like this. So you can observe the principal axis. Now this ray, how these two are parallel to each other, that's why the light ray passing through the focus after incident on the concave mirror, and it is reflected like this, and the reflected ray and principal axis both are parallel. So this is for what? As convex mirror. Now let's discuss about the S. This is the concave mirror. Okay, and in this case we are drawing the like this here. This is the incident ray. This is what? Incident ray. So the incident ray seems to be here, it is S. The incident ray is coming towards focus. In case of concave mirror, what I have to say? The ray is passing through the focus, and now in this case the incident ray is coming towards the focus, it is not directly passing through the focus. You have to remember that. Simply we are extending the incident ray, and after that the reflected ray is how it is? Parallel to the principal axis, This is the pole of the convex mirror. For convex mirror, the reflected surface is inward, so non-reflected is inward and reflected is outward. Got it, children? In this case the ray is passing through the focus, after reflection is parallel to the principal axis, and in this case the incident ray is coming like this, and there seems to be passing through the focus. It is coming towards the focus, not passing through the focus. After reflection these two are parallel. Now rule number 3. If the ray is passing through the center of curvature, then reflected ray also passing through the same center of curvature. This is the third rule you have to remember. Okay, if the ray is passing through the center of curvature, then reflected ray also passing through the same center of curvature. So that is we are going to discuss in case of the first concave mirror. This is the concave mirror, and this is the principal axis. So to draw this one, we have to draw the size of the mirror is some little bit more compared to the previous one, then only it becomes very easy to draw. Now this is the ray that should be passing through the center of curvature, So now this is the pole, and this point is focus, and now this is the center of curvature, and here it is the incident ray. This is what? Incident ray. To understand which is the incident ray and which is the reflected ray, we have to identify the arrow marks. So now arrow mark is towards mirror. This is the concave mirror, that's why this is the non-reflected surface, outward is non-reflected surface. Clear? And now after incident that one, the same ray is passing through the passing the same center of curvature. This arrow mark indicates the ray is moving towards the mirror, reflected surface of the mirror, and this arrow mark is represents the wave is moving, and it is the moving through the C, and it is the reflected ray. So this is simply ray diagram for this situation, third rule, and we have to draw the same thing for convex mirror. And this is the principal axis. Clear? And here the ray seems to be moving towards this is the ray. We are drawing like this, and that seems to be here. So this is the center of curvature. Of the second diagram. No need to confuse. This is the second. This is what for convex mirror, and this is what? Concave mirror. Clear? This part belongs to concave, and this part belongs to convex. Here the incident ray seems to be like this. That should be moving towards center of curvature. So as usual, this is the pole, and this point is the focus, and this is the center of curvature. So the incident ray seems to be moving towards center of curvature. Then the reflected ray is also moving in the same like that. In which path it is coming? In the same path it is going again. So from this point you can observe, we can see that the reflected ray also passing through the center of curvature. Clear? In this case, directly what you have to say, the incident ray is passing through the center of curvature. But in this case, what you have to say, the incident ray seems to be or towards the center of curvature. It is not exactly passing through the center of curvature. You have to observe the difference. In this case, the ray is towards the center of curvature. Then reflected ray also seems to be, it is moving from center of curvature. So this is for convex and this is for concave. Rule number 4. If the ray is incident obliquely at the pole with the same angle, that is going to be reflect back. That is the rule number 4. If the light ray is incident at the pole with certain angle, with the same angle, the ray is going to be reflect, and in this case loss of reflection can be obeyed. Look here, this is for now concave mirror. This is what? Concave mirror, and that is the principal axis. This is the pole. Here what we are saying, the ray is incident obliquely like this at the pole with the same angle, that is going to be reflect. Clear? So it is what? This is the concave mirror. This is what? Concave mirror, and this is the incident ray, and this is the reflected ray, and this is the angle of incidence, and this is the angle of R. So this is the principal axis. Now it is pole, and this is the center of curvature. What I am telling, the ray is incident obliquely with certain angle at the pole. Again, in the same manner, that is going to be reflect. In this case, angle of I is equals to angle of R. That means first law of reflection is applicable. And now here, if you can go for convex mirror, further time also same thing here. So this is the principal axis, and this is the incident ray, and now it is going to be reflect like this. This is the reflected ray. You have to observe this one. So this is the convex mirror, and this is the non-reflected surface, and this is the reflected surface, and this is which mirror? Convex mirror. Convex mirror. Clear? So with what angle that is going to be incident? I, and this is the R. So in this case also angle of I is equals to angle of R. So if you want to extend them, you can extend like this. This is the incident ray, and this is what direction of reflected ray, and this is the pole, this is the focus, and this is center of curvature. In this case